Okay, so in the first problems that we're going to look at, basically because we've got equals on these equations, you're looking at what value of x makes the equation true. And these that 1 through 4 is listing here, you've actually done some problems like this before, and you did them in Math 2 and then probably in Math 1 as well. They might not look as complicated as these might look, but you've done this before. So let me remind you what that looks like, and then we're going to talk about some other kinds of rational equations where we want to solve for x. So notice it says by cross multiplying is how we want to solve it. This only works if you have fraction equal fraction. If you'll notice at the bottom here, you've got fraction plus fraction equals another number. You can't cross multiply on these problems, only on these right here where it's a fraction equal to a fraction. So what you do, I always start wherever x is, and you sort of multiply crossways. I think somebody told me that in middle school, maybe you called it the butterfly method, so maybe you've heard that before. When you multiply, like the 5 times that, the 5 has to multiply by the x, and the 5 also has to multiply by the 5. So that would be 5x minus 25. And then you also multiply 4 times 15, and you get 60. From there, we're going to add 25 on both sides. So you get 5x equals 85. And then divide both sides by 5. And I think that comes out to x equals 17. Any questions about that one? Like I said, cross multiplying, this is something that you've done for a while. Just maybe not as in the problems as complicated as I'm giving you today. So when we do number 2, again we're going to do 15 times both of the things. So 15x minus, I think that will come out to be 90. Once you multiply one side, you set it equal to what you get when you multiply the other side. So 3 times both things, which would be negative 6x, and then negative 6. And then we solve. So we combine for the x's and then we solve. So we want to add 6 on both sides. 6x, sorry. Add 90 on both sides. And then we want to divide both sides by 21. I'm running out of room there, but know that whenever I'm getting my answer here, I'm dividing by 21, and so that we get x equals 4. Number 3 is a very similar kind of problem. The only difference is that on the right it just has a 4, but we're going to make it look like a fraction to do the same thing, so just make it 4 over 1, and then we cross multiply inside. Alright, so when I work it out here, I've got 5x times 1, which is 5x. 4 times both of those, so that's going to be a 4x minus 4. Combine to get my x's together, so subtract 4x on both sides. That does give me an x, and then equals negative 4. Now, number 4 is just a tad bit different, and the reason is because there's a little bit of multiplying that you have to do to solve it. So let me show you what I mean. So here I want to multiply x plus 3 times x plus 7. Now, the hard part here is that x has to multiply by the x and the 7. 3 has to multiply by the x and the 7. You're going to get 4 things when you multiply this. Think of it like using, some of you have heard FOIL, some of you just did the distributive property, whatever's easier for you to think of. So I'm just going to start with x, and I'm going to multiply x by x, and then x times 7. So that would be x squared plus 7x. Then I'm going to do 3 times x, and then 3 times 7. So that would be 3x, and then 21. Okay, then we're going to multiply the other side. So x has to be multiplied by, and it doesn't matter which one you start with, but if I just started with this one, I'm going to multiply x by x and then x by 2. So x squared plus 2x. Then I'm going to take the 1 and multiply by both things. So 1x, and then 1 times 2 is 2. Okay. After you have it multiplied out, then you can combine and move and do everything that you need to. First of all, I would probably subtract x squared on both sides. If I subtract x squared on both sides, the x squareds totally go away, so that's nice. And then I'm going to combine the x's, so I have 10x plus 21 equals 3x plus 2. And again, the x squareds went away because I subtracted it on both sides, and you get 0. To finish that problem, I'm going to subtract 3x on both sides. Then I'm going to subtract 21. And then divide by 7. And oddly enough, it is okay to get fractions when you're doing these questions. Fractions or decimals are perfectly fine. The only thing that you have to be careful of on these kind of problems is that you don't get an answer that is at an undefined place. And a lot of times it won't matter, but you kind of look back at the problem and anything that's on the bottom, like I can't get a -1 or a -7 because if I did, I would have a 0 on the bottom. Here I can't have a 1 because I would have a 0 on the bottom. So it's just something to think about, that if you are cross multiplying, you should always make sure you don't get one of those undefined places. Now, cross multiplying doesn't always work. And that's why we need to go to the next sort of kind of problems. Now, there are several ways that you can solve it, and one way is to do what we've done before. Like we can add these together, get a common denominator, make a fraction out of it. Once we have a fraction, then we can cross multiply and solve. And if you would like to do that, go for it. I want to show you another way to do it by graphing, which is basically using Desmos. And I think you'll like it. That particular way, you can also do 1 through 4 that way as well. I just wanted you to see how 1 through 4 would work because I felt like it was something that you would know how to do. So, here's what you're going to do. So, in Desmos, you're going to enter, move this over a little bit to make sure you can see it all. So, everything on the left, you just enter it the way that you see it, 5 over x plus 1 over 3, except 1 over 3 can't be on the bottom. I need to move it over. 1 over 3. Oh, goodness. There we go. And then it says equals 1, so what I'm going to do is I'm going to make it equal to 0, like we've done in the past with other kinds of problems where we said move it over and make it equal to 0. So I'm going to subtract 1 on both sides to make it equal to 0. And then just put it on Desmos, and then your answer is wherever it crosses the x-axis. Just like, you know, when we solved quadratics and we said move it over and make it equal to 0 and look for the zeros. We're doing the same thing. We're moving it over. We're looking for the zeros. It's possible there's more than one. A lot of times it'll be that gray highlighted point that's on the x-axis. Just click on it. Looks like 7.5 is our answer. Not really much work to have to do. On number 6, same process. It's just that when we move it over, it just looks a little bit uglier. Okay? So we're going to leave the 2 over 5x and the 1/3, but I want to subtract this over. Equals 0. And then I'm just going to put it in Desmos just like that. 2 over 5x plus 1 over 3 minus 4 over 15x. And and I can sort of tell that there looks to be a point there because that point was grayed out. If you need to zoom out just to make sure you can, or we could have went to home. But it looks like that our answer is negative 0.4. Okay, so in number 7, when I put that in Desmos, I get 1 over x minus 3. Be careful how you put it in, obviously. It's so easy to mess up there. And then I'm going to move that whole fraction over. So when I move it over, it's just minus, and then 4x divided by x plus 2. And notice there are 2 places where it crosses the x-axis, and that is okay. We get negative 1 and 0.286. Alright, and then on the last one there, we'll have 3 over x minus 1 plus 1 over x plus 1 minus 10 over x squared minus 1. And again, we're looking for the gray dots that crosses the x-axis. Don't click on every little gray dot that you see. We're only wanting the one that crosses the x-axis, or 2 or 3, however it does. It's only one. So it looks like 2 is our answer. Just be careful about that, and don't just pick every answer that you see. Make sure you pick the gray dot that equals 0. This other one kind of looks like it could be 1, but notice it's not equal to 0 on the y, so it can't be that one. Okay? Alright, so now we're going to look at some word problems, and we're going to solve the word problem similarly to this. It's just that we have to set it up first on how we solve it. So here's the process, and then we'll turn it over and look at the actual work. You're going to calculate the work rate, which is the amount of time for each person. These problems are called the work problems, and what it is it'll be, most of the time it's 2 people, and they're working on a job, and for one person it might take them a certain amount of time to do a job. For another person it takes them a certain amount of time, and what we're trying to figure out is how long it would take if they did it together instead of separate. Or if we knew how long it took them together, how long it would take them to do it separately. And so what we figure out is we use the amount of times that we know and we divide it by the time. And then in the final answer, you're going to take the rate for the one person, you're going to take the rate for the other person, and then you're going to equal that to the rate forever, or rate together. And the rates will always be fractions, which means our answers or problems are going to kind of look like this right here. Okay? So let's look at an example. So number 9 says, working alone, it takes Rob 10 minutes to sweep a porch. May can sweep the same porch in 11 minutes. If they work together, how long would it take them? So Rob, it takes 10 minutes. May can sweep it in 11 minutes. And we're looking for how long it would take together. So when we talk about the rate, it's the way that I think about it is the type of job divided by the time. And so in this case, it takes Rob 10 minutes to do one job, which is sweeping the porch. So one job takes 10 minutes. We're going to add that to whatever the job is that May can do, which in this case, it takes her the same job, which is only one job, takes her 11 minutes. How long will it take them to do it together? So that same one job together is x. And so that's the equation that you set up. So you do whatever kind of job it is divided by the time on each, you add it, and then that equals to whatever that same job is divided by whatever you're looking for. Okay? After you have it set up, and you just go to Desmos and solve it the way I was just showing you to solve it. So you do 1 over 10 plus 1 over 11. Subtract that 1 over x minus 1 over x, and then figure out where it crosses the x-axis. So when we talk about how long it's going to take together, should it be more or less than the amount it takes separately? It should be less. And so when you get your answer, if you don't get less, you know you did something wrong. And in this case, we got that amount of time, which is less. And so together, it's going to take them 5.238 minutes. Okay. And that's pretty much the process on all of them. Sometimes instead of a 1 on top, you might have something different. And let me show you what that means in number 10. Molly can pick 40 bushels of apples in 11 hours. Elia can pick the same amount in 12 hours. If they work together, how long would it take them? Okay, so if they're picking 40 bushels of apples instead of just one job, we're going to do 40 as the job because there's 40 bushels that they're picking. So for Molly, she picks 40 in 11 hours. So 40 over 11. Elia can pick the same amount in 12 hours. So 40 over 12. If they work together, how long would it take them then? They still want to pick 40. So 40 would be on top. And then X is what you're looking for. Now, because they're picking 40 bushels of apple each time, you actually can put 1s instead of 40s. It really doesn't change your answer. But if, for example, they said that Molly could pick 40 and Elia could pick 20, that's the only time that might change where it really matters. Okay? All right, so then to solve it, we're going to put 40 over 11 plus 40 over 12. Move over that 40 over X. So minus 40 over X. Notice I didn't put that in, right? There we go. We know we should get less than 11 and 12. And we did. And we got 5.739 hours. So together, that's how long it would take them. Now, in number 11, it asks the same thing, except this time they tell me how long it takes together, and we're looking for how long it takes someone to do it by themselves. It just means that our X is going to go to a different place. Okay? So Ryan and Lisa can pick 40 bushels of apples in 6.24 hours. This is together, because it says that's how much they can do together. It doesn't say the word together, but that's what that is. Had she done it alone, it would take Lisa 13 hours. How long will it take Ryan to do it alone? So we're going to add Lisa and Ryan and equal it together. Okay? Because we don't know Ryan, that's where the X is going to fall. Okay? We're still picking 40 bushels of apples. Again, you can put 40 or you can put 1, whatever makes sense to you. I'm going to put a 1 on this one, but again, you can put the 40. It doesn't hurt anything. So, together is the 6. Lisa is the 13. So 1 over 13 would be Lisa. Ryan is 1 over X, because that's what we don't know. And then we set that equal to 1 over together, which is the 6.24. Again, you can put 1s or 40s. Since it's the same number of things that everybody's doing, it really doesn't matter. Okay? So again, let's put it in here. 1 over 13 plus 1 over X minus 1 over 6.24. And for that, we got 12 hours. That makes sense that we got Ryan to be more than they did together. And so it looks like it's going to take Ryan 12 hours to do it alone. Alright, so we know that Kristen, it would take 9 hours. We want to know how long it would take Jasmine, so we would have 1 over 9 plus 1 over X for Jasmine, and then we know together it's the 4.24, so 1 over 4.24. And then when we put this in Desmos, minus 1 over 4.24, and I think you get around 8, so it would take around 8.017 hours. Alright? The next one's a multiple choice question, and it's just odd the way that it's written. If you do get a decimal, just be sure to try to match it up with these, or change these to decimals to make it match up. Okay, so on this one, we were asked how long it would take for them to do it together. And so we know that we're looking for 1 over x. And so Brad's 1 over 2, Chris is 1 over 3, so you work that out. You do get 1.2 when you work it out. And then trying to change that, there's several ways you can do it, but one way is to realize, well, it's 1 point something, so it has to be either B or C. And then if you put 1/5 in there, and 1/6, I can tell that it's the one with the 0.2, so it's got to be the 1 and 1/5. That would be one way to check it. Okay? Alright, there's another kind of word problem I want to show you real quick. Not really this kind, but a kind that still is related to rational, and so I want you to see this. In number 14, it says that we have a cost. C is a cost. And we're building an oil platform. It's X thousand tons, and then it gives you an equation. And so A says, what is the cost per ton for 30,000 tons? Okay? And so what I notice in the problem is that X represents thousands of tons. And in A it says 30,000 tons. So 30 is what X represents. So to do A, what it's asking me to do is to take that equation and plug in 30 where X is. That's all A was asking me to do. So that's really nice. It's just going to come out to be an answer. It's not an equation. And that should be 625 instead of a 325. And so you get 477. It's talking about cost, so I'm going to round it to 2 decimal places. So either 0.09 or 0.10 for the cost. So sometimes all you might have to do would be to plug in whatever the value is in for X. Okay? In B, it says how many thousand tons was the platform if the cost per ton was 483. In this question, they're telling me that we know the cost and we want to figure out how many tons. So the difference is that we know the C. So 483 is going to go where the C is. And you end up with an equation that you have to solve. Okay? And for this equation, you can just do it in Desmos the way that we have been doing them in Desmos. So we would have 483, and then we want to subtract over whatever's on the right. I have to zoom out as we try to find the answer, but it looks like that our answer is around 22,000 tons. Or if we don't round it, 21.998 tons. So the only difference in these problems as compared to the ones above them is you're just trying to decide, are they giving me X or am I trying to find X? And you just have to figure out where to plug it in at. Okay, so on the first one where it says, what is the cost per unit when 590 are produced? 590 does stand for X, so you would just put the 590 in the X place, and you would get that. And then once you solve that, you get 0.5, which makes sense because it says cost per unit, and so that means how much does one of them cost. And so that's why it's a small amount. B says if the cost per unit is $1.50, how many have been produced? The difference in B is that 150 is the cost, so you have 150 equals 300 over x plus 10. And then when you put that in, if you do 1.50 minus 300 over x plus 10 and solve that, you will get 190 units have been produced. And so that's the final answer.